Unit for review, Problem 5. Use the sample data collected in Problem 4 to construct all pairwise comparison confidence intervals to estimate the difference in the mean serving temperature of a cup of coffee at Starbucks, McDonald's, and Dunkin' Donuts with a simultaneous confidence level of 95%. Interpret the results. So this problem asks us to use the sample data collected in Problem 4. So the serving temperature of coffee at Starbucks, McDonald's, and Dunkin' Donuts data we analyzed in Problem 4 will be used here in Problem 5. So all this data should be entered into our calculator already. Starbucks is taken as the first population, McDonald's is our second population, and Dunkin' Donuts is our third population. Now, using this data, we're asked to construct all pairwise comparison confidence intervals. So we'll be conducting confidence intervals, but we need to do all pairwise, that is, two population comparisons at a time. So for our three populations, Starbucks, McDonald's, and Dunkin' Donuts, we need to just compare them two at a time, or pairwise. That is, we need to do a confidence interval that compares Starbucks to McDonald's, and Starbucks to Dunkin' Donuts, and then McDonald's to Dunkin' Donuts. This would require three pairwise comparison confidence intervals. Here we're going to estimate the difference in the mean serving temperature of a cup of coffee. So our confidence intervals are estimating the difference in the means. mu1 minus mu2 is the difference in the means between Starbucks, the first population, and McDonald's, the second population. The second confidence interval estimates mu1 minus mu3, which is the difference between the first population, Starbucks, and the third population, Dunkin' Donuts. And our third comparison confidence interval estimates the difference between mu2 and mu3. mu2 is the mean serving temperature at McDonald's, our second population, and mu3 is the mean serving temperature of coffee at the third population, Dunkin' Donuts. To do this, we'll be constructing confidence interval estimates, comparing two populations at a time, that's the pairwise, comparison confidence intervals for the mean serving temperature of a cup of coffee. So this means we could follow these steps to construct our confidence interval estimates. The first step in a confidence interval is to decide upon the level of confidence. Typically, we use a 95% or 0.95 confidence level. And here the problem even states, let's construct our confidence intervals with a simultaneous confidence level of 95%. But we're going to be calculating three different pairwise comparison confidence intervals. That means simultaneously we want all three of our confidence intervals to be accurate at the 95% confidence level. In order to do this, the three pairwise comparison confidence intervals need to use an individual confidence level of 1 minus alpha of a cube root of 0.95 in order to maintain our simultaneous 95 or 0.95 confidence level. So because we have the three confidence intervals, we're doing the cube root, and since we want the overall simultaneous confidence level to be 95%, we use the 0.95. Now that we know the level of confidence we're going to use, we can then calculate the lower and upper end of the confidence interval to estimate the difference in these two population means using the 2samp tint command on the TI-84 calculator. Since we'll be constructing three separate confidence intervals to do all pairwise comparison confidence intervals, we'll have to execute this 2samp tint command three separate times. First, to compare Starbucks, the first population, to McDonald's, the second population, we'll construct the 2samp tint command using the list1 and list2 data. And since we want a 95% simultaneous confidence level between all three of these confidence intervals, we'll use the individual confidence level for each confidence interval to be the cube root of 0.95 or 0.983 decimal. To get to the 2SAMP TINT command on the TI-84 calculator, you press Stat, arrow over to Tests, and then arrow down till you find the 2SAMP TINT command. Press Enter to select. The calculator will prompt you for the input. Your choice is data or stats. Since we entered the actual sample data into lists, we make sure the blinking cursor is on data and press Enter to select. Down arrow. With the blinking cursor next to list 1 prompt, we enter in second 1 for list 1. Press Enter. And now with the blinking cursor next to list 2 prompt, we press second 2 to bring up list 2 and press Enter. Freq 1 and Freq 2 are the frequencies for the list 1 and list 2 respectively. Here we're going to use the defaults of 1 because each of the temperatures entered into list appeared on one day. So now we down arrow with the blinking cursor next to C dash level, and this is where we enter the confidence level for this individual confidence interval we're about to construct. Since we're going to be constructing 3 different confidence intervals, to have an overall simultaneous confidence level of 95% or 0.95, we need to do each individual confidence interval at the cubed root of 0.95. To do this, we press Math, arrow down, press Enter to select the cube root function, and then we could type in the 0.95. Press Enter, and the calculator will calculate the cube root of 0.95 in decimal form, 0.98304. Now the cursor is next to pooled. For us, we are not learning how to do the pooled approach, so it will always be no. So make sure the blinking cursor is on no and press Enter. Down arrow to calculate. With the blinking cursor on calculate, we press Enter, and then we have our results displayed. So looking at the displayed results on our screen, we can then construct our first pairwise comparison confidence interval. Here, comparing Starbucks and McDonald's. We do this by writing mu1 minus mu2, surrounded by the less than signs to show that this estimate for the difference in the two means is between. And the calculator provides us with L, the lower limit, and U, the upper limit. Looking right underneath the 2SAMP TINT command, in parentheses, is displayed the L, the lower limit, separated with a comma, from U, the upper limit. Here, the lower limit of the interval is -12, and the upper limit is -5.424. You could use all these decimals, but if you want to round off, make sure you round off carrying at least one more decimal place than the accuracy we need in the problem. In this case, we could round the -5.424 to the nearest tenth of a degree Fahrenheit and get -5.4. So here, the first pairwise comparison confidence interval can be written as mu1 minus mu2 in between the less than signs, and -12 on the low end and -5.4 on the upper end. Now that we've calculated this confidence interval, we need to interpret the result. That is, we need to, in words of the problem, communicate or describe what this result is telling us. Since mu1 is the mean serving temperature of a cup of coffee at Starbucks, and mu2 is the mean serving temperature of a cup of coffee at McDonald's, and this confidence interval is estimating mu1 minus mu2, We're actually estimating the difference in the mean serving temperature between Starbucks and McDonald's. Here, the estimate says it's somewhere between negative 12 degrees Fahrenheit and negative 5.4 degrees Fahrenheit. And this estimate is made at the 98.3% confidence individually. But in the end, when we combine it with all three of our intervals, we'll have a simultaneous confidence level of 95%. Here, since the lower limit is a negative value, negative 12, and the upper limit is a negative value, negative 5.4, we get negative differences when you take a lower number minus a higher number. So in this case, mu1 would be lower and mu2 would be higher. That's why we get these negative differences. Thus, this makes Starbucks have a lower mean serving temperature than McDonald's. So here's one way we can give this interpretation in words. The mean serving temperature of a cup of coffee at Starbucks is estimated to be anywhere from 5.4 degrees Fahrenheit to 12 degrees Fahrenheit lower than that at McDonald's. So here we've interpreted and calculated our first pairwise comparison confidence interval. Now we need to do this for the rest. Going with the second pairwise comparison confidence interval, comparing the first population, Starbucks, to the third population, Dunkin' Donuts. Here we have to execute the toSampTint command a second time. But here we'll use L1 for the data at Starbucks and L3 for the data at Dunkin' Donuts. To calculate the confidence interval, to estimate the difference between the first population mean and the third population mean, you press Stat, arrow over to Tests, arrow down to select the toSampTint command, press Enter. We have data selected, and we're comparing the first population mean, where the sample's in L1, to the third population mean, where the sample is in list 3. Second 3 brings up list 3 next to our list 2. So now we're comparing the list 1 sample to the list 3 sample to get the confidence interval estimate for the difference between the first population mean and the third population mean. Everything else is the same, so we just down arrow to calculate, press Enter, and we get our results. While looking at the results on the screen, we can then write our second pairwise comparison confidence interval. To do this, we'd write mu1 subtract mu3 in between the less than sign symbols, and then the calculator provides us with the lower estimate and the upper estimate. Here, the lower end of the confidence interval is negative 2.79, and the upper end of the interval is estimated at 7.3612. We could use all these decimal places, but if you want to round off, make sure we round off carrying at least one extra decimal place for accuracy. So here, the lower end is negative 2.8, and the upper end is rounds to 7.4. So here we've constructed the pairwise comparison confidence interval that compares the mean serving temperature of a cup of coffee at Starbucks, mu1, to the mean serving temperature of a cup of coffee at Dunkin' Donuts, mu3. And it's constructed this way. Negative 2.8 is less than mu1 minus mu3 less than 7.4. Now we need to interpret the results. That is, we need to write a sentence in words of the problem that interpret what this confidence interval is telling us. Here, since the lower estimate is a negative 2.8, and the upper estimate is positive 7.4, this leaves the possibility that 0 is in between, because 0 is a value that's in between the negatives and the positives. And when 0 is a possibility, this means that the mu1 minus mu3 could be 0 or no difference. So we can give our interpretation. Since the confidence interval ranges from a negative value to a positive value, thus including 0 in the interval, we conclude that there is no significant difference in the mean serving temperature of a cup of coffee at Starbucks and Dunkin' Donuts. So now we've calculated 2 of the pairwise comparison confidence intervals and interpreted both of them. We're now ready to do the third and final confidence interval. Here we're comparing the second population, McDonald's, to the third population, Dunkin' Donuts. This requires us to execute the toSampTint command using the list2 and list3 sample data. To calculate the confidence interval to estimate the difference between the second population mean and the third population mean, you press Stat, arrow over to Tests, arrow down, and select the toSampTint command, enter, and then we just need to change list 1 to list 2 by pressing second 2 next to the list 1 prompt. We'll leave list 3 the same next to the list 2 prompt, and everything else stays the same. This way we'll get the confidence interval that estimates the difference between the data in list 2, that is from the second population mean, and using the data in list 3 to estimate the third population mean. Arrow down with the cursor blinking on calculate, press enter, and we get our results. So looking at the results on this calculator screen, we can then write down our third pairwise comparison confidence interval by writing mu2 subtract mu3 in between the less than symbols, and then the calculator provides us with the lower estimate. Here we get 5.8282, which rounds to the nearest tenth of a degree Fahrenheit to 5.8. And the upper end of the interval, 16.172, which when rounded to the nearest tenth of a degree Fahrenheit, we get 16.2. Now that we have our third pairwise comparison confidence interval calculated, we can then interpret this result. Here we're interpreting the difference between mu2 and mu3, that is between the McDonald's and Dunkin' Donuts mean serving temperature of coffee, is estimated to be somewhere between the 5.8 and 16.2. Since 5.8 is positive and 16.2 is positive, this means subtracting mu2 and mu3 led to a positive difference. Positive differences are the results when the first value is higher and the second value is lower. That's because a higher mean subtract a lower mean always leads to a positive difference. So here we could say mu2, the mean serving temperature of a cup of coffee at McDonald's, is higher on average than mu3, the mean serving temperature of a cup of coffee at Dunkin' Donuts. So here's one way we can give our interpretation of this result. The mean serving temperature of a cup of coffee at McDonald's is estimated to be anywhere from 5.8 degrees Fahrenheit to 16.2 degrees Fahrenheit higher than that at Dunkin' Donuts. So now that we've interpreted each of our 3 calculated pairwise comparison confidence intervals, we have successfully answered this question. That is, we have calculated each of the 3 pairwise comparison confidence intervals and then have provided 3 written interpretations of each of these calculated confidence intervals. Here, just to summarize our interpretation, we could say the following. Thus, the mean serving temperature of a cup of coffee at McDonald's is anywhere from 5.4 to 12 degrees Fahrenheit higher than that at Starbucks, and anywhere from 5.8 to 16.2 degrees Fahrenheit higher than that at Dunkin' Donuts. Furthermore, there is no significant difference in the mean serving temperature of a cup of coffee at Starbucks and Dunkin' Donuts.